Welcome. We're here at Premcrete HQ today. I'm Jason Devenish and I'm joined by Clive Tuffin. We're going to be presenting to you today a CPD about threefold substructure protection in the context of the Building Safety Act. Threefold substructure protection, what do we mean by that? This is waterproofing, gas protection and ground heave protection. So just to set the scene for today's presentation, what we're going to seek to do is unpack some of the complexity that lies within the Building Safety Act. We certainly wouldn't claim to have a full understanding of the entirety of the Act, and we understand that we're presenting to construction professionals. What we have done is some significant research in the context of substructure protection, and we hope that this will be helpful for you. Before we move on, I'm going to hand over to Clive to talk about Premcrete in a little bit more detail.
Okay, so just to kick off with a brief introduction to Premcrete as a company before we move on to the educational part of the CPD. For starters, Premcrete is a company that's been established for over 40 years. At the outset of the company, we were a distributor for many of the major global manufacturers of construction chemicals, structural waterproofing, gas protection systems. The business was acquired by its current ownership in 2005, and since then we've been on a mission and have now completed our mission of establishing the Premcrete brand. We are a British manufacturer in our own right, so whether it be pre-applied membranes, gas-resistant DPMs, watertight concrete additives, we're producing everything in-house within our factory in Hampshire. As a company, we have a significant drive of sustainable innovations, of which some we'll be including today in our presentation. Our vision, mission and values. This can sound a bit cliche, we appreciate, but we do live and breathe these as a company. Our vision to become the most respected in the field comes through in what we do every day of our lives here, which is our mission, to be a trusted partner that is depended upon to consistently provide outstanding technical and commercial support. We look at everything that we do through the eyes of what's in it for the customer in terms of value engineering designs, looking at the right technical solution for projects. And lastly, our values. We're genuinely passionate about what we do. Most of our team have been on the tools at some point in our lives, which does bring a different dimension to our level of support on projects. We love the construction industry. Secondly, our integrity. We believe this shines through in our transparent ways of operating in relation to our warranties. And lastly, innovation. It's at the heart of everything we do, and we'll touch on a few of our new elements that we're looking into and developing in the industry currently. So we work in a busy marketplace. There's a lot of people doing similar to what we do. We wouldn't claim that our products are particularly stand out compared to other manufacturers, while certainly they do have some unique features. We do believe these 4 points here are what set us apart in the industry. Firstly, design. We take on design liability as covered under our PI, which we carry as standard to a level of 5 million. And we have an in-house pre-construction design team, which gives the ability to develop designs very quickly for clients. Secondly, our agility as a company. Whilst we're certainly not a small company today, we are relatively small in comparison to some global conglomerates that work in the market space with us. This means that director level input is fundamental on lots of key projects, able to make very quick decisions to support you. Thirdly, commercial support. Through years of experience on projects, we're aware of the real challenges that present themselves on projects, whether it be overusage of projects due to technical detailing that's not right, whether it be general management of project call-offs. We're on a mission as a company to support contractors with clear commercial reporting where required. And lastly, we are independent. As a company, our relationship with you as a designer or a ground worker or indeed a warranty provider, there's a direct relationship one-to-one. Moving on to our 4 key aims today for the CPD presentation. Firstly, we hope to define the impact of the Building Safety Act on substructure protection. Secondly, we want to develop your understanding of what the critical considerations are for you in relation to waterproofing, gas protection and heat protection on your schemes. Thirdly, we look to raise your awareness around the importance of quality control systems, compliance and competence in relation to the Building Safety Act. And lastly, we want to simplify what is quite a complex standard in terms of our field of works. So, what is the Building Safety Act? Certainly not what everyone's idea of bedtime reading is. A 254-page journal, 404 pages of explanatory notes. This is a significant piece of legislation for the construction industry. Our mission today is to unpack what's pertinent in relation to substructure protection. Moving on, the foundation of the Building Safety Act has been born out of the tragedy at Grenfell, 14th of June 2017, Many of you, I'm sure everyone in the UK is familiar with what that really meant for this country. It was a moment in time when there was a tragedy as a result of specifications being changed. The Building Safety Act is aimed at advancing comprehensive reforms to the building safety system and addressing concerns which have primarily been highlighted following Grenfell. Indeed, this is for all of construction. Historically, and even in recent months, many of us have thought this is just fire-oriented. But this Building Safety Act is for the whole of construction. It relates to high-risk buildings, what we'll be referring to from here as HRBs, and this is effective with a hard start from the 1st of April 2024. So just to define what a high-risk building is, these are buildings which are 18 metres or higher, or 7 stories. And they must contain at least 2 residential units, including hospitals, care homes and student accommodation. Hotels and prisons and other similar usage of buildings, these are covered by a separate piece of legislation outside of the Building Safety Act. So there's some really key new roles and responsibilities outlined within the Building Safety Act. The Building Safety Regulator is a new role now responsible for the signing off and approval of designs. They're going to oversee the safety and standards of all buildings, and they lead the implementation of this new regulatory framework. Building control, this is what the Building Safety Regulator has become, ultimately headed up by HSE, who are going to be acting as the building control for projects across this industry as related to the higher risk buildings. We are aware that there's going to be other bodies such as building warranty providers that in time may be able to develop into this capacity too. Lastly, duty holders. These are key people that are responsible within a project. Firstly, we have the client. Secondly, we have the principal contractor. And then thereafter, we have the various designers. And lastly, the specialist designers. That's where we come in. And essentially, this is very much bringing into harmony BS 8102 with the Building Safety Act. The latest update of BS 8102 in 2022 highlights the importance of having a specialist waterproofing designer involved as early on in the process as possible. And lastly, on this summary introduction to the CPD, we just want to cover off on the key gateways that the Building Safety Act has introduced. Firstly, we have Gateway 1. This is essentially the key planning stage of a project. Our understanding of this is that there's possibly not a huge amount of change to how projects have worked historically. However, once planning has been received and the journey to Gateway 2, which we'll go through in more detail shortly, there's a lot of changes here. And the key element for all of the construction industry to be aware of is the 12-week approval period to gain approval once you've submitted your application for Gateway 2 to then gaining your final approval. The final stage, Gateway 3, is the pre-occupation phase. So once a project has completed, O&M manual information is submitted, there's a 12-week phase where there's the approval being carried out by the Health and Safety Executive. That building cannot be occupied until the completion certificate has been issued. Moving on, the golden thread is a key term that runs all the way through the Building Safety Act. Now, throughout this presentation, we'll seek to help you to understand how the golden thread can be applied to the waterproofing design right from the early concept design stage all the way through to your project completion. So, we have the 3 gateways of the Building Safety Act, 7 stages of REBA design, and we have 4 segments within Prem 360, which is the process that powers our whole design engine as a company.
So we've come up with this timeline, which is designed to help align these various processes. We've talked about Prem 360, the REBA stages and the 3 gateways of Building Safety Act. How do they all line up? Well, let's have a look. So the first stage of the Prem 360 process is concept design. This is where we'd normally come up with a high-level strategy. This ties in with REBA stages 0 through to 3 and also is the process that leads up to Building Safety Act Gateway 1. So the next phase is detailed design. This is where we would normally be engaged to undertake a detailed design for the waterproofing and take the full design liability. This ties in with REBA stage 4 and this part of the process is what leads up to Gateway 2 in the Building Safety Act. The next stage is site support. So this is where the project is now live, we're on site. This ties in with REBA stage 5, which is the manufacturing and construction phase, and this is the process that leads up to Gateway 3, which is pre-occupation. And then of course you've got project delivery, which lines up with REBA stages 6 and 7 and is part of the process that is beyond Gateway 3 when the building has been occupied. So we like to make our CPDs a little bit interesting, and what we've done is we've likened the timeline for the Building Safety Act to the London Underground. So we'd like to invite you on board the Premcrete Express. And we're going to take you on a little bit of a journey, unfolding the best practice sequence of events in relation to substructure protection design and the gateways of the Building Safety Act. So firstly, prior to the planning stage, there's actually a lot that we as a waterproofing specialist and designer can do. For example, there's always a ground investigation report or a site investigation report that is produced at the very early stages of a project prior to planning. From that report, we can understand the gas risk, whether there's hydrocarbons in the ground. We can even get information as to the water table and the soil types, and also understand if there's a heave protection requirement. So the next step is for us to determine the use of the structure. Clearly this needs doing before the planning stage anyway, but the use of the structure directly impacts the grades of waterproofing. Depending on the gas risk, we can then specify the gas protection solution. We can understand if there's hydrocarbons that we need to protect against, and we can also specify any heave board if heave protection is a requirement.
Throughout this presentation, we've interspersed it with some really key learnings around British standards, some of our key product systems, and also some highlights of key projects that we've worked on, where there's some critical sort of design hacks, as we call them, around better ways of detailing to be more groundworker friendly. So kicking off to start with here, we have the BS8 102 2022. This was updated nearly 2 years ago, and it's really important the industry does get up to speed with familiarity around the new grades of protection. Grade 1A is what we know of historically in relation to the 2009 standards as the old Grade 1. This is where seepage dampness is acceptable in your basement. Grade 1B is what we've been used to knowing in relation to 2009 standards as Grade 2. This is where dampness only passing through the structure is acceptable. Moving on to Grade 2. This is a new grade of environment that the 2022 standards has introduced. Essentially, we as a designer would still include two forms of protection because dampness and water ingress is not permitted passing through the structure. However, dampness can occur within the structure due to a lack of ventilation being provided within the environment. And lastly, Grade 3, a completely dry, habitable environment, the same as it has always been. BS 8485 2015. There was a further annex amendment in 2019. In brief, BS 8485 outlines how we protect a structure from gas ingress. Firstly, we have a characteristic situation. This is the levels of gas ingress through the ground in your given site. Sites will be classified from CS1 to CS6. Every building that we construct is then classified as a type A, B, C or D. And lastly, there's the amalgamation of those two elements into achieving what's needed as a gas protection score for your project. What's really important is that we understand that we must score points from 2 of 3 core areas. Firstly, we have the membrane protection. This is a gas membrane itself. This contributes 2 gas protection score points, regardless of the system. Secondly, we have the structure itself. The actual reinforced concrete structure plays a really key part in stopping gas ingress into your building. Indeed, the incorporation of waterproofing enhances gas protection score points further. And lastly, we have ventilation. So whether it be mechanical ventilation within a car park, or maybe a ventilation mat incorporated underneath your structure. This also is a key area of achieving points for your structure. So to highlight, we must achieve points from any 2 of those 3 elements. So as you can see from the visual provided there, as Premcrete, we're manufacturers of all core waterproofing and gas protection systems. So whether it be a combined gas and waterproof membrane, a gas-resistant DPM, or a ventilation protection membrane, we can support what's ever required for your project. Understanding ground heave. So ground heave is nothing new to the construction industry. It occurs due to the expansion of clay soils when they absorb water and presents a challenge to the structure, potential cracking within your ground-bearing slabs. The traditional solution has been through polystyrene-based products. However, we don't believe clay is the only upheaval on your project. We believe polystyrene is. These types of systems have caused numbers of challenges for contractors, whether it be excessive dig requirements, bulky products on the project, easy damage resulting in excessive waste, and lastly, harmful to the environment. So, welcome to VoidTech. This is an innovation which we're now launching to the market. Key elements around it are firstly, it reduces your dig depth. Secondly, It's flat packed on delivery to site. Thirdly, it deploys in seconds. And lastly, it's polystyrene free, providing a very high strength and durable product for use on your project. So let's take an example project. Based in London, 1,420 square metres, clay plasticity of 40 to 60%. The next couple of slides go over the key savings that this product can bring to your project.
So firstly, 13% dig reduction, saving on muck away, time and costs. Secondly, 87% less deliveries, that's 8 lorries to 1 in this scenario. There's 96% saving on unloading time and an equal 87% reduction in storage on site. Also, there's 25% faster install, easy to cut with a Stanley knife. There's less wastage, there's less bulkiness of waste, and it's completely polystyrene free. So when we take into account all the savings on this case study, we're looking at a £10 per square metre reduction in cost, aside from the cost of the product. On this project, this equates to over £15,000.
So, back on the Premcrete Express, we're just going to hop off at a recent project, Taxi House. This project presented the challenge from the contractor's side. It was gas protection, there was pile caps within the basement, and they did not want to wrap those pile caps. Having recently, at this point in time, gained approval for the hydroproof LG, liquid applied gas membrane, certified for both water, gas, VOC, and also demonstrating its performance in terms of coefficient of friction, this product was approved for its use as being applied over the top of the pile caps, saving significant time and money from traditionally wrapping the pile caps with a membrane. So once we've understood the ground conditions of the project, determine the use of the structure, it's then our part to provide, at this stage in time, quite a high-level strategy around the substructure design. So firstly, we need to start off with the waterproofing. We've understood what we're building, we've hopefully understood the typical grades of environment that are needed. What types of waterproofing do we need to incorporate? Once we've ascertained that, we'll look to provide a high-level GA plan to assist people at an early stage, whether it be main contractors, developers, or the architects and engineers. You may wonder why we're looking to establish such detail on design prior to planning. But as a company, we've worked with a number of developers at an early stage prior to planning, and we do see that it does help on planning approvals, particularly where there may be contaminated sites. If there's a clear mitigation strategy presented by a suitable, qualified professional around gas protection and waterproofing, that can be presented as part of the planning submission to help expedite the approval. So let's have a quick look at the 3 types of protection in relation to BS8 102. Type A, this is referred to as barrier protection. This comes in the form of pre-applied membranes, self-adhesive membranes, and liquid-applied solutions. Type B, this is our watertight concrete additives. Typically, the technology of watertight concrete can be crystalline-based additives, or also pore-blocking technology. The Hydrocrete watertight concrete additive that we work with provides a combination of this within the dual AC technology, providing you with the best of both worlds and a more robust solution. Incorporated within the Type B protection is also the water bars, so your hydrophilics, your PVC water bars, and also steel blade water bars, which we tend to use for kicker joint applications. And lastly, Type C, drain protection, internally installed cavity drain membrane. This can also incorporate externally applied drainage membrane solutions. So to summarise, in terms of Type A, B and C products, as a manufacturer, we specialise in the full holistic range of products, therefore ensuring that there is a single source warranty. So, moving along the line to Hammersmith, the West King Street project was a scheme that we've been involved in over the last couple of years. This particular project presented an opportunity for the liner wall to be cast in front of the capping beam. This was a preference of the groundworks contractor. By installing the liner wall in front of the capping beam, significantly reduces the volume of watertight concrete used on the project. As you can see on these examples here, installing waterproof concrete within the capping beam, let's say a typical 1.2 by 1.5 metre capping beam, a significant volume of additive goes in there, increasing costs considerably, whereas installing a 200 to 300 mil liner wall in front significantly reduces the costs.
So let's assume that we've got past Gateway 1 and we've achieved our planning permission for the project. The first thing that we need to do is reconfirm the specification. So we need to reconfirm the grades of waterproofing. These can change depending on the use of the structure, which can be influenced at planning stage. We also need to reconfirm the ground conditions. Sometimes gas risks can be remediated, but other times hydrocarbons might be discovered. We actually have a greater risk to deal with. Also with ground heave, sometimes this can be designed out or designed in depending on what's happened through the planning process.
So, moving along the line to Mayfair. The One Mayfair scheme was a project that we've been involved in for approximately 4 years now. Our initial involvement was a couple of years prior to the work actually starting on site. The benefits this project highlights is by bringing on a waterproofing designer early on in the process, helps to streamline design decisions that benefit both the client and the contractor long term. This project had some real challenges around maximising the floor area. The original design was to exclude any form of a lining wall in front of the secant piles. Bearing in mind this project was 5 stories deep, also if you're interested had 7 swimming pools incorporated within the structure. The client was very concerned about their return on investment on this scheme. Originally the intent was to apply waterproof coating to the secant piles. We as a designer weren't comfortable about this considering the level of risk on the project. It then looked at the option of applying shotcrete to the liner walls. As a designer, manufacturer, we're concerned about the quality of the concrete to which we'd be applying our products to. Finally, they resorted to a 90mm nominally reinforced concrete skin wall. The end result was a really good quality substrate for our waterproof coating to be applied to. The application of a waterproof coating was a fundamental part of the design from early on. End result was we had a design solution which created an excellent substrate for the application of our products, just highlighting the benefits of including waterproofing design as early on in the process as possible.
So now we're at the part of the process where the waterproofing designer can be engaged to undertake a detailed design. In Building Safety Act, there's a big emphasis on competence of supply chain, and that's why we've highlighted a few points here which you should be looking out for as a main contractor or developer or architect or structural engineer when you're selecting the right waterproofing manufacturer. Ideally, a waterproofing manufacturer, in our opinion, should have an in-house design discipline and capability. Also, you need to check with your waterproofing manufacturer whether their PI insurance covers the waterproofing and the gas protection or combined, because sometimes this is not always the case. Your waterproofing manufacturer should also be able to advise you whether they can train up your groundwork contractors on the site or whether the project is more suited to a specialist installer. Additionally, you should be checking to see whether your waterproofing manufacturer has got a proportionate number of CSSW certified and qualified designers in their team, proportionate to the size of your project.
So, we'll take a quick trip under the Thames over to Wandsworth, to our Smugglers Way project. As related to the earlier project we looked at Taxi House, this scheme occurred immediately prior to it, admittedly in the infancy of the hydroproof LG being launched to the market, and we did find some approval challenges coming through from the structural engineers. Reasons for the challenges was historically products being coated over the top of pile caps would limit the shear connection between slab and pile cap, which is a really fundamental joint to have a good quality shear connection. Hence, traditionally, the wrapping of pile caps, gift wrapping, has been a typical method of application for that reason, but also in relation to gas protection for the reason that there are no products certified on the market for gas, water and VOCs that would be acceptable for overcoating. However, considering the fact hydroproof LG was fully tested for the coefficient of friction, gave suitable confidence to the structural engineers that it was emulating the same quality of bond as a concrete-to-concrete connection. So clearly, a certified solution to protect against water, gas and VOCs that has this level of certification to give the assurance to the engineers is really important for this change in detailing.
So in the process of scrutinising the supply chain, specifically for the waterproofing, what we do need to do is understand the warranty requirements. Number one, the length of the warranty, whether there's different warranties for different scenarios, and also whether a collateral warranty is going to be required from the main contractor. Not all manufacturers provide a single source warranty for a set period of time across all of the products on their scheme. And also, not all manufacturers will offer a collateral warranty. The other very important thing to identify very early on in the process is whether an insurance-backed guarantee is required, otherwise known as an IBG. This is an increasing issue on projects where the groundworker gets to the end of the installation and then they're asked to provide an IBG. We need to know whether an IBG is required very early on, which would either point to the need for a specialist installer, or it is indeed possible for groundworkers to be able to provide an IBG on a project-by-project basis.
So we're moving on down the line to 9 Elms. 9 Elms Park is a large-scale development that we've been working on over the last couple of years, not dissimilar to the couple of previous projects we've highlighted in terms of the need to overcome gift wrapping pile caps. However, this project had the added complication of a very large transfer beam. It was a challenge for the contractor to understand whether there would be advantages in wrapping the membrane due to the scale of the transfer beam, or whether to overcoat in a liquid applied product. The final decision, which was a commercial-based one, was to overcoat the top of the transfer beam, speeding up both the program for the installation of this large element of works and also making the life for the installers that bit easier on site. Another key element of this project was early engagement, looking at redetailing of the conti bar positioning to the underside of the capping beam. This is a very regular detail that gets done on pretty much every basement scheme. However, through engaging early, looking at the preferences of the ground workers and incorporating this into the design can make for a much more workable solution on site. More often than not, there's the opportunity to offset the conti bar box within the liner wall to provide enough space behind it to install your hydrophilic water bar. If this is not reviewed early on, then the other solution is to install hydrophilic water bars to the top and the bottom of your conti bar box, which is both costly and time consuming.
So as we continue to move through scrutinising our waterproofing manufacturer, we also need to understand what sort of training they offer. Firstly, do they offer training and technical support right at the early stages for architects, structural engineers and design teams working for the main contractor? And also we need to understand whether there's training available for the site installation team.
A key pillar of the Building Safety Act is competence, ensuring there's competence not only in the designers, but indeed in manufacturers, providing support to the installing contractors, and all the way through the project journey, making sure there's a level of competence being maintained. As a manufacturer, we have a responsibility to be constantly sharpening the saw and making sure that we're providing adequate support to contractors. The Premcrete Academy has been established for a short while, and this covers a whole range of levels of support to a project, whether it be off-site training days at the manufacturer's headquarters, on-site training days and toolbox talks throughout the course of a project, or indeed making sure that the contractors are suitably familiar with the process in maintaining the quality control regime. Whether it be online, offline methods of training, all are very important in today's digital world. We'll take a short trip to North London to the Whittington Hospital development, which we worked on a couple of years ago. This scheme highlights the importance of combining good quality site training with value engineering designs. So, as you can see, the image highlights the ability of being able to install a membrane directly onto a variety of substrates. This project had a contiguous piled wall. Many manufacturers may require a skin wall or a facing up of some kind to be applied to those piles prior to the installation of a membrane. However, if there's membranes that are suitably flexible, can be fixed due to the self-healing nature of the product, then there is no reason why the product cannot be applied directly to the piles, providing the contractors have suitable training. So, we're now at a stage where the detailed design should be complete, having had the suitable supply chain scrutiny taking place through the contractors and the specialists providing their detailed level of design and input to finalise a REBA Stage 4 design that's suitable for application to the Building Safety Regulator. At this point in time, we are ready to process into an application for Gateway 2. So before we discuss the journey from Gateway 2 to Gateway 3 in too much detail, we're just going to have a quick visit to the Malt Street project. This project was one where the ground worker had had previous challenges on schemes where compaction of concrete in the liner walls to the underside of the capping beam had presented some issues. Water ingress is a typical problem at this interface. Through early stage engagement and the incorporation of tremie pipes within the capping beam enables a really smooth transition of concrete pour for the liner wall detailing. This overcomes the issue of concrete compaction to the underside of the capping beam, which all too often doesn't give sufficient compaction around the hydrophilic water bars, and thereby failure can occur.
So as we move from Gateway 2 through to Gateway 3, we can now assume that the Building Safety Regulator has approved the Stage 4 design and we're now okay to start on site. So as part of the supply chain scrutiny that's expected by the Building Safety Act, in order to have competent suppliers, manufacturers, installers, we do need to look at what needs to happen during this site delivery stage. So some of the questions that we need to ask ourselves is there an in-house design capability to cope with on-demand design changes during the duration of the project? There's always going to be something that crops up that wasn't included in the original detailed design, and it's very important that manufacturers can act quickly to produce designs that are required as the project progresses. Another question we need to ask of the manufacturer is, will there be hands-on support available if problems or challenges occur on site? It's very important that we really understand the practical nature of how things are built and understanding the practicality of the problems that the groundworkers face on a day-to-day basis on their projects. Furthermore, we need to understand that all the core products and systems that are specified for the waterproofing design do have agreement certificates and the relevant certification and testing in place. And finally, we need to ensure that there's going to be a robust quality control procedure on site, and the manufacturer is going to be in attendance and doing their inspections, but also providing the training to the ground workers or the specialist installers as to how to use the quality control app, Premtrack.
Moving on to a quick piece around the importance of robust, digitalised QC platforms. Quality control portals are becoming ever more fundamental as a result of the Building Safety Act. As a company, we've invested heavily over the last decade on developing and customising our very own QC portal, which is also app-based. This very much is coming into its own with the requirements of Building Safety Act, making sure we have that golden thread of an audit trail, traceability right from early stages of design discussions all the way through to the on-site delivery process. Premcrete is a portal that ensures not only training registers are recorded, but also ensuring that every single concrete pour has a valid and QA-checked quality control report per pour. In brief, how it works for a contractor is prior to every pour, there would typically be an engineer from the contractor on site who would be marking up on the interactive GA plan the location of the concrete pour, completing pre-pour check sheets relevant to the system that's being installed. Those check sheets would come back to us as the manufacturer to approve. Likewise, our site operatives, when they go to site, would be providing the same level of quality control. Essentially, a twofold method of reporting is ensuring a much more robust level of QA to then present to the clients. A key element also around Premcrete is its functionality to support the O&M manual submission. On completion of projects, a single download click can be pressed, which will export all things relating to the waterproofing or gasproofing installation, including drawings, photos, any non-conformances that may have arisen across the course of the project, and indeed their subsequent closing out and the final warranty inspections as well.
So in holding the waterproofing manufacturer to account, we do need to make sure that the project deliverables that were agreed upon at an earlier stage are being upheld. Are deliveries coming to site in a timely fashion? Are the products in stock? Are they attending the quality control visits regularly and as promised? And finally, are they being true to their values, the environmental practices and the quality control practices that were outlined at the beginning of the project?
So moving along, our final case study of the CPD is over in East London, the Wickside development. This project presented some real challenges at capping beam level, with soft, crumbling piles that needed to be overlaid with a structural grade blinding. In actual fact, this presented an excellent solution for projects where you may have contiguous piling. The installation of a structural grade concrete blinding over the top of the piles, as you can see on the small image on the bottom right-hand corner, shows a very simplified detail for applying liquid applied waterproofing at this zone. Typically, with this kind of method of construction, detailing around individual pile heads would be necessary, which is not only laborious, but a high area of consumption for materials. Secondly, this project had a number of large box-out areas for pipe penetrations. What's really important to people in the design stage is understanding the importance of leaving sufficient gap between the pipes to enable full detailing of the waterproofing around this critical interface.
So now we've got past Gateway 3 and we've got our completion certificate from the Building Safety Regulator and the building is ready to be occupied. It is important that we hold the manufacturer accountable in the event of a defect post-occupation. What is the strength of the service level agreements that are in place between manufacturers and ground workers or specialist installers? Are they holding true to their product warranties and collateral warranties? Do they have an in-house remedials team, or what is their approach to remedials? If a defect occurs, it's very important that the manufacturer takes full responsibility to resolve the situation in line with their warranty. And finally, is there traceability of QC reports in line with the golden thread of information that's required by the Building Safety Act?
Okay, so that does bring us to the end of the line. It is the close of the CPD. Just to recap on the 4 key aims that we had from the CPD. Firstly, we trust it's been helpful in defining what the Building Safety Act means in relation to substructure protection. Secondly, understanding what the critical considerations were in relation to substructure design. Thirdly, raising the awareness of the importance of quality control, competence, all in line with the golden thread requirements. And lastly, we hope in some way we've helped to simplify what this really means for you. Finally, if you would like to receive your Premcrete CPD certificate, then please take a moment to scan the QR code and complete a brief quiz to summarise your understandings, your key learnings from our presentations today. Thank you very much for watching.